Good day everyone! Today, we're going to discuss about number system. So what is number system? Number system, also known as numeral system, is a writing system used to represent numbers, a mathematical symbol used to represent a specific set of numbers in a consistent manner using digits or symbols. The same sequence of symbols can represent different numbers in different number systems. Number systems have four main types, and these are binary, octal, decimal, and hexadecimal. So what are these and how do we convert all of these to each other? Let's find out. Our starting point will be binary.
Binary is a type of numeral system represented in a base 2, which consists of 1 and 0. For example, 11011101. This set of numbers is a form of binary numeral system. So how do we convert binary to other numeral system? Let's start the calculation.
Let's first convert binary to octal. Our example will be 11011101 base 2. Now let's first break these digits into groups of 3 with each starting from the last. So it's 101, 101, and 1. But since the last part is just 1, so it'll become 101, 101, 100. The next step is to multiply each groups of number by 2 in exponential function chronologically. That means putting 1, 2, 4 under these numbers and start multiplying. So 1 times 1 is equals to 1, 0 times 2 is equals to 0, then 0 times 4 is equals to 0. Add the results of the first group and we'll get 1. Let's do the same for the other groups. So 1 times 1 is equals to 1, 0 times 2 is equals to 0, 1 times 4 is equals to 4. To sum the second group up, we'll get 5. Since the third group is the same with the second group, the answer is surely 5 also. Put the results in reverse and we'll get 155. So the conversion from 11011101 base 2 in binary is equivalent to 155 base 8 in octal. Next is to convert binary to decimal. The set of binary is still the same, 11011101, but the process will be different. Now let's place each of these numbers vertically starting from the last digit. The following step is to multiply these digits by 2 in exponential functions starting from 0 and above. So the process will be 1 times 1 is equals to 1, 0 times 2 is equals to 0, 1 times 4 is equals to 4, 2 times 8 is equals to 8, 0 times 16 is equals to 0, 1 times 32 is equals to 32, 1 times 64 is equals to 64. Next thing is to add all of these up. Since 109 is the sum, then 109 is the decimal form of 11011101. Lastly, let's convert binary to hexadecimal. Let's stick with 11011101. So first is to break the set into groups of 4 starting from the last digit. Then it should become like 1011 and 011. Then add 0 to the last part to make it 4. Then place 1, 2, 4, 8 under each group and start multiplying it. So 0 times 1 is equals to 0, 1 times 2 is equals to 2, 1 times 4 is equals to 4, and 0 times 8 is equals to 0. Then sum all the results up and we'll get 6. Do the same for the second group. 1 times 1 is equals to 1, 0 times 2 is equals to 0, 1 times 4 is equals to 4, and 1 times 8 is equals to 8. Sum it all and we'll get 13, which is equivalent to D. Join the results in reverse together and we'll get 6D. So, the hexadecimal form of binary 11011101 is 6D. That's all for the binary. Now let's discuss the second type of number system, which will be octal.
What is octal? Octal is a type of numeral system that is base 8 and uses 0 to 7 digits. For example, 175 base 8 is a form of octal numeral system. Let me show you the process about the conversion from octal, other type of numeral system.
First is octal to binary. Since we use 175, let's separate these digits, then put 4, 2, 1 under each groups. Since 1 is the only number that can come up with 1, the conversion will be 0, 0, 1. Since 7 is the sum of 1, 2, 4, then the conversion will be 1, 1, 1. Lastly, 5 is the sum of 1 and 4. That's why 1, 0, 1 is its conversion. Then let's put each group together and we'll get 0, 0, 1, 1, 1, 1, 1, 1, 0, 1. Erase the zeros from the first part because it's unnecessary. Therefore, our final answer for octal to binary conversion is 175 base 8 to 1, 1, 1, 1, 1, 0, 1 base 2. Now let's convert octal to decimal. Our octal is still the same, 175. Let's place our octal numbers vertically starting from the last digit. So it's 571. Next is to multiply each with 8 in exponential function chronologically starting from 0 and above. So it'll become 5 times 1 is equals to 5, 7 times 8 is equals to 66, then 1 times 64 is equals to 64. Next is to add all of these results up. Therefore, our answer for octal to decimal conversion, 175 base 8 is equal to 125 base 10. Next is octal to hexadecimal conversion. Our given octal is still 175 base 8. First things first is to find out the binary of our octal, which we already found out earlier, 111101. Next is to rearrange the numbers into groups of 4 starting from the last digit. So, 1011 and 1110. Next thing is to put 1, 2, 4, 8 under each group, then multiply it. So, 1 times 1 is equals to 1, 0 times 2 is equals to 0, 1 times 4 is equals to 4, and 1 times 8 is equals to 8. To sum these all, we'll get 13, which is D in hexadecimal system. Next is 1 times 1 is equals to 1, 1 times 2 is equals to 2, 1 times 4 is equals to 4, and 0 times 8 is equals to 0. Now to sum it all, and we're getting 7. Put the results in reverse and we'll get 7D. That means the hexadecimal form of octal 175 is 7D. And that's all for octal. Next up is decimal.
Is a type of numeral system which is base 10. Since it covers from 0 to 9, 220 base 10 is example of decimal form. How to convert it to other types of numeral system? Let's start calculating.
First is the conversion of decimal to binary, and we have 220 base 10 as our given example. First things first is to put the simplified form of 2 in exponential function reversely, which are 256, 128, 64, 32, 16, 8, 4, 2, and 1. Since 256 is greater than 220, then let's exclude 256. Is 128 greater than 220? No, that's why let's subtract 128 from 220. And then the difference is 92. Can we subtract 64 from 92? Yes, that's why we'll continue subtracting. 28 is the answer. Can we subtract 32 from 28? No, so we'll skip that and start subtracting with 16, which is okay to use. Since we can subtract 8 from 12, let's put 4 here. Lastly is 4 minus 4. That will equal to 0. Therefore, we can subtract with 2 and 1 anymore. We can see that 128 plus 64 plus 16 plus 8 plus 4 is equal to 220. Thus, our calculation is correct. Now, let's convert this. Since we have 128, so 1. We have 64, so another 1. We don't have 32, so 0. We have 16, so 1. We have 8 and 4, so 1, 1. And we don't have 2 and 1, so 0, 0. Then, the final binary form of 220 base 10 is 11011100 base 2. Next is decimal to octal. Since our given decimal is 220, we'll divide it to 8, which would equal to 27.5 with a remainder 4. Next is take the 27 and divide it with 8, then we'll get 3.375 with a remainder 3. Lastly, take the 3, divide it with 8, then we'll get 0, and its remainder is 3. Let's rearrange all of the remainders from bottom to top, and we'll get 334 base 8 as the octal form of 220 base 10. Last thing will be decimal to hexadecimal. The same with octal, let's divide our given number, which is 220, but into 16. We'll get 13.75 with 12 as the remainder. Next is take the 13 and divide it with 16. Then we'll get 0 and 13 as the remainder. Now, if we convert 12 and 13 into hexadecimal system, 12 corresponds to C and 13 corresponds to D. The same with octal, let's rearrange the remainders from bottom to top, and we're getting DC, base 16 as the hexadecimal form of 220 base 10. Now, let's proceed to the last type of numeral system, hexadecimal. Hexadecimal is a type of numeral system that uses 16 symbols, and that's why it's base 16. The symbols used are 0 to 9 for ones and A to F for tens. 5E2 base 16 is an example of hexadecimal form. Now let's start conversing. First is to convert hexadecimal to binary. With 5E2 base 16 as our given example for hexadecimal, we're going to separate and put 8421 under each symbols. So 5 is the sum of 1 and 4. Therefore, what we're getting will be 0101. Next is do the same for E, and E corresponds to 14. Since 14 is the sum of 2, 4, 8, then we're getting 1110. Now for the 2, its addends is only 2 based on the given choices. Therefore, we're getting 0010. Now put all results together and we'll get 1011110010 base 2 as the binary form of 5E2 base 16. Next is the conversion of hexadecimal to octal. We're still sticking with 5E2 as our given example. First is to find out the binary form of our hexadecimal, which is the result from earlier. Next is to rearrange the set into groups of 3 reversely. So the form will become like this. And then put it in reverse again. Next is to put 4, 2, 1 under each groups, then start taking numbers next to ones. In 0, 1, 0, we can only see 2 with 1, therefore we'll be getting 2. Next is 1, 1, 1, means all of them. Add 4, 2, and 1, then we'll get 7. Next is 1, 0, 0. The only number with 1 next to it is 4, therefore we'll be getting 4. Lastly is 0, 1, 0. 2 is the only number next to 1. That's why we will have 2. Next is to put all the results together, and the answer we'll have is 2742 base 8. That means 5E2 base 16 corresponds to 2742 base 8. Then last is to convert hexadecimal to decimal. Our given hexadecimal is still the same, 582 base 16. So first, let's separate each symbol and multiply it with 16 in exponential functions starting from the last digit. Means 2 times 16 to the power of 0, e which is 14 times 16 to the power of 1, and 5 times 16 to the power of 2. So this means 5 times 256 is equals to 1280. 14 times 16 is equals to 224, and 2 times 1 is equals to 2. Add all the results together and we're getting 1506 base 10 as our decimal form for 582 base 16. So that's all for today. Thank you so much for watching and we'll see you guys next time.